Well, hello everyone, welcome back to Adrian's Digital Basement 2. On today's video, we're going to be taking a look at some radio stuff. Now, this is going to be a totally random video, and it's not really about the radio, and the radio in question is a Quansheng, I think it's a UV-K5, UV-K5, I think UV-K5 is the model number of this radio. What I want to look at today is actually the charger that comes with the radio, because the radio comes with these little charging bases to charge the lithium-ion battery, which I think is like a 8.4 volt battery, so it's a 2-cell lithium-ion battery. And the idea is you stick this into one of these charging bases, like so, to charge up the radio, or the battery in the radio. Now the funny thing is there are two variants of this radio, one that's got this sort of plastic rugged look, and the other one has a more of a flat front. I have that one upstairs. And the weird thing is when I ordered these, is the one that has the plastic front, the black plastic front like this, it comes with a charger that has a USB connector and a USB-A. And then the other one comes with a charger that's got mains input. And the chargers look identical. I mean, in every way, even the bottoms are the same. So I want to open these things up and take a look at what's happening inside, because obviously a 5-volt USB plug on its own is not enough to charge a 2-cell lithium-ion battery. So the USB one must have some type of step-up circuitry inside. But this is what really got me confused when I got both of these, is what's written on the bottom is literally identical. Input 110 to 240 volts. And then separate charger input, 10 volts at 500 milliamps. Output 8.4 volts at 500 milliamps. That's about the right charging voltage for a 2-cell battery. Notice that is exactly the same on both of these. But as you can see, one has a regular mains input and one has USB. And neither have any kind of other inputs on them whatsoever. Both weigh basically nothing. C51, C51. I mean, I need to know what's inside of these. And just the fact that they are light as a feather just sort of sucks. If anything, if there's room inside to just put a fake metal plate in the bottom, plus some rubber feet on the bottom, to keep this from sliding around so easily would be advantageous. Putting the radio in, it's just, I mean, yeah, it's junk. But as far as these radios go, I mean, there are plenty of videos online you can watch about how they work and stuff like that. These are pretty awesome. They can be modded with aftermarket firmware. They are $30 on Amazon. There are the two variants. I didn't really know what the difference is between the two, but to be honest, I can't really tell, because when you look at the back, both of them have the same FCC ID, UV-K5 model number. The stickers look a little different on the other one. Let me go grab the other one. Yeah, this is what the other one looks like. So the case seems to be the only actual difference. I haven't peeled off the plastic on this one yet. The one on the left has a flatter appearance on the front, but it isn't actually thinner. It seems to stick out further, if anything, compared to this version that has this sort of bulge going on. It's kind of amusing that for a $30 radio, $30 to retail, this is the price you would pay to have it shipped to you, that they even bother to make two different, cosmetically different versions of these radios that seem to be identical otherwise, at least as far as I can tell. And I tried doing a little bit of reading online, and I couldn't really find any differences between these two radios. But this version, which is the one that I have less experience with because I just got this the other day, this is the one that came with the charger that has the AC plug on it. And it's this one that came with this USB version of the charger. Oh, there is one other difference, by the way, and this one has an amber backlight, and this one has a white backlight. Yeah, that's it. Right now, the firmware that's on this one on the right is the aftermarket firmware. I can't remember the name of it. And this one is running the stock firmware. I haven't even done anything to this thing at all. I haven't programmed it. Finally got the peel off this one. It's nice that this protector's on there, but it had some scuff marks on it, and that was when I took it out of the box. So that's kind of annoying. Looks like there's one on the logo as well. Now, by the way, when it comes to these radios, I call these things toy radios, because that's sort of what they are. At $30, they're kind of disposable at the price, and it goes without saying that the performance of these radios, compared to good quality mobile handheld radios, these are lackluster at best. But they're 30 bucks, and for $30, you get a lot for your money. You really do. And obviously, this is not the original antenna. This is the original antenna. I've swapped that one out for a better one. If you go look online for Quansheng, you'll find tons and tons of reviews of these radios, and if you just Google around, you'll find the aftermarket firmware for them. But I don't think anyone has ever actually shown what's going on with these chargers. So let's open these things up. I really want to know what exactly is going on. Are these even safe to use? I have a feeling the ones with the mains input, this one's got to be like a capacitive dropper. It's just got to be. This thing doesn't weigh anything. But who knows? Maybe we'll be surprised when we get these open. And I don't know. They're going to be better built than I think. Now, one possibility as well is maybe this isn't a capacitive dropper. Maybe this has just a very cheap little USB power supply. So it goes from mains down to 5 volts. And then this one just emits the mains voltage stuff, and it just takes the USB directly. I've only used the USB one for charging, and it totally works. I haven't even tried this mains one. So, okay, yeah. Let's open this one up and look what's going on. I mean, at least as I take the screws out of this one, the mains one, I'm sure it's a single-sided PCB. At least there is some amount of separation. That's good, because this section over here, this is what is the low voltage side. This is what, goes to these pins that are on that are exposed. So if there was something going on, like a short between the mains and the low voltage side, you could touch those pins, which, depending on the safety of your house electrical system, could be pretty dangerous. It goes without saying, the USB version, on the other hand, it doesn't have any of those safety concerns, because you're just dealing with 5 volts DC in. It would have been nice if this was USB-C on the end of that cable. I mean, and this thin cable is just as crappy as can be. But again, price point, right? We're talking about very inexpensive. Okay, so they are different on the inside. All right, so let's compare a little bit. Right off the bat, we're clearly dealing with exactly the same plastic molding, which is why all of the markings on the bottom and on the top were identical, but totally different PCBs on the inside. Let's focus first on the USB version. So 5 volts USB comes in. Notice there's nothing actually connected besides the 2 power leads. That means your charger may or may not give full current to the USB-A connector, because generally you want to have, I think, the data pins with a resistor across them. That can actually tell your charger, okay, you need to give 2 amps. What we don't really know is how much current that this charger can supply to the battery. Now, looking at the rest of this, at the instruction quality on it, let's see if I can pop this out. I don't want to break it, because I do need this to work to charge my radio. How does this come out here? There we go. Okay, just like I thought. So USB comes in, goes to a bulk capacitor, 220 microfarads, 16 volts. Dual color LED for charging, the charging contacts that touch the battery itself. And it's hard to know if the battery inside the radio here has any kind of BMS or anything like that. 7.2 volts, 1600 milliamp hours, 11.52 watt hours, BPK5. I don't know if anyone's done any capacity testing on this battery, or if anyone's making any aftermarket ones, but there is a PCB in there at the minimum. It's obviously a pouch cell, cells, plural. BMS might be in there for a little bit of charge protection. I've heard it's possible to actually charge these batteries through the radio, and that's because, if you notice, this has a USB-C jack on it. Now, the weird thing is, when you plug that in, there's nothing obvious that shows up on the screen. You don't know that it's actually charging or not. The aftermarket firmware does show the battery icon with charging percentage, and you can look at the battery voltage or change it to say the battery voltage. Programming on the radio is just like on other radios, and it's happening through the headphone microphone jack, which is kind of unfortunate. I was hoping it would use the USB for that purpose. Now, in the manual for the radio, that is, it talks about charging via the USB. It doesn't really talk much about it. It just says some versions of the radios will charge with the USB, and it's for emergency use only, and do not remove the battery while you're charging. So it's kind of saying, if you have the USB connected and it is charging the battery, if you take the battery off, potentially the radio could be damaged. I haven't taken one of these radios apart to kind of look into that, and I also don't know if it does charge, because the radios, unfortunately, I haven't really run the battery down enough to be able to tell if it's charging or not. And maybe it's possible like the USB charging works on this flat front version with the orange screen. Not totally sure on that. Anyhow, back to this board. So bulk capacitance for the incoming USB, then we have an IC that's clearly controlling the charging along with this inductor. So to have a boost circuit, you usually need an external inductor unless there's some trickery going on with capacitors and the charging IC. We have some diodes and we probably have a transistor. Maybe that's like a safety shutoff thing. And like I said, the dual color LED, which looks like it's just driven directly off the charging IC. Let's see if I can read the part number on the IC, because I certainly can't with the camera. Yeah, I can't read the part number because there is none. It's not been sanded, it's just literally got no freaking markings on it. Which sucks, because otherwise we could have looked up the data sheet to at least see how quick the charging is. There's another cap right there, this one, and that's going to be used for the output, whatever voltage output from the charging IC that goes into the battery. Almost certainly, at least this USB one seems, I would say, decent. I mean, without looking at this chip, we don't know for sure. But most likely when you plug in the USB, you get 5 volts here. It boosts it up to probably 8.4 volts, which is the maximum charging current for that type of battery. And it will limit the current, so probably in an idle state, you'll just get 8.4 volts on these two contacts, which we can test in a second. And when you hook up the battery, that will drop, especially if the battery's lower on charge. And this will give probably, what does it say on the bottom of this, 500 milliamps to the battery? 500 milliamps at 8.4 volts. And the voltage will slowly rise to 8.4 volts. And I guess as the current going to the battery starts dropping, the chip probably detects that and then swaps the LED over from red to green. So this circuit probably works just fine and charges the battery without issue. And it probably does it in an okay and a relatively safe way. Okay, so let's plug the charger into my battery bank. I see the LED came on as red and now it's showing as green. And there it is. On the pins, we're getting exactly like I thought, 8.4 volts. And I'm sure if we start drawing any kind of current, it will change the LED from green. Actually, the LED is just off right now. So that's interesting. So it actually has an off state, which, oh yeah, look at that. It is off right now. Oh, you know what? It's off because the power bank turned off. There we go. I was thinking it had some kind of like power saving mode. Nope. So it overshot a little bit when it charged up. What I'm curious about with the radio is what do we get on these contacts on the back? Let's see here. Oh, you just get battery voltage. I'm not particularly surprised. This is just direct battery voltage. And I don't know if that's just normal standard operating procedure for most things like this. These types of packs that are on radios. What about like better ones like Motorola and stuff like that? Is the battery voltage just exposed on the back pins? Maybe. I don't have any of those radios to even test with, but I don't know. I'm slightly surprised by that, but I guess I don't know why I am. All right, PCB clips in quite easily. Let's put the radio into there. Charger not connected to anything. The light does not turn on. I kind of recall some other cheap radios I've had in the past that it does. So now we should have battery voltage. There we go, 8.0 volts. Let's plug the USB in. Let's see what we see now. Yeah, 8.2. Okay, that means it can slowly kind of creep up all the way to 8.4 once it's done charging. The red light's on, you should just be able to see that. And yeah, I mean, that works. As far as the firmware that's on here, it's telling me I have 99% battery. That's not really believable. Okay, it's dropping. I guess that's not accurate because it doesn't know the battery is charging or not charging. So the battery voltage probably has dropped to like 8.0 or 8.1. There it is. Battery volume, 97%, but 8.16. Let's see what happens when I put this in the charging base. And yep, there it is. It's raising up. You know, that's kind of cool in a way. I mean, saying 100% battery is 8.3. Maybe that's good. I don't know. The folks who made this firmware have fine-tuned the battery voltage stuff. But that's actually kind of cool that you can see that as the radio is charging. You can change the percentage on the battery icon at the top there, also to voltage, if that's what you'd rather look at. But this does show us that it's definitely still charging. We pop this out. The light takes a second to switch over to green, and I assume there's like some hysteresis in the circuit on the little charging IC that prevents this from flickering. So, like I said, decent design. What would probably help is the room in here. this goes on like that, there's some space. You could put a lead weight in here to give this thing a little bit more substance than it has now, because it's just feels like nothing. Okay, let's focus on this version. This is the AC mains version, the more dangerous one. Testing this one is going to be a little harder because it's obviously a little bit more dangerous. So mains input, bridge rectifier, bulk capacitor, which is what voltage? 4.7 microfarad at 400 volts, so that's good. You wouldn't want to have that too low if you're going to plug this into 220 volts, 240 volts that is. So the rectified DC is smooth, and then it goes into that IC. And notice there's no real charging circuitry, at least that I can tell. So this little board, it does appear to use a switch mode design. So almost certainly everything is integrated into this one little IC. And because this is so low current, it doesn't need to have external MOSFETs, things like that. And the fact is, and you can see that we have 4 pins on this side. That's probably a feedback winding. So there's the primary, the secondary, and then feedback. And that allows this IC to do a little bit of voltage regulation. So on the secondary side, this will be AC, of course, high frequency AC, and this has half bridge rectifier or just a single diode. And then this cap is the reservoir cap, that is the voltage. Let's see what that is, 16 volts probably, 105 rated. 470 microfarad at 16 volts. So same as the other one actually. But the thing about this one, what I don't like as much is the charging circuitry for the battery in the radio is not as sophisticated. It's just taking the DC that comes off the switch mode converter and then what? I mean, we have a little 3-pin package, transistor maybe, there aren't any silkscreen markings, and a little 4-pin package, which some type of regulation, and another 3-pin package. So I'm not really as smart at reverse engineering these circuits as, say, Big Clive, but I'm sure this is not as sophisticated or as good of a charging circuit as the other charger. And I'm just noticing right now that they had shaved the markings off this switch mode controller. Okay, so I plugged this thing into an isolation transformer. Now don't do this unless you know how to do it safe, because obviously we're talking about high voltage DC and AC over here. I mean, there's mains voltage right there. Okay, so let's look at the DC voltages outputs, 9.7 volts. So it takes that 9.7 volts DC, and then this just regulates it very simply. Let's take a look at the battery contacts. There it is, 8.39. So yeah, 8.4 volts. This board is fine. I'm just gonna unplug it here. It's fine. The difference is all the safety on this particular device from you getting a shock by touching these contacts is coming from the quality of the transformer that's on the top. And who knows how good or bad that is. If that thing is badly made and the insulation on the windings is not good quality, then it could break down. And then it could be giving you primary voltages on the secondary side, which, as you notice, one side of it goes directly to the charging pin on the negative side. And on the positive side, there's just this little bit of circuitry here. And if this stuff got damaged or blew out or whatever, and then you could suddenly have full mains voltage available on these pins. And if you touch them like that, that would be very bad. So you're relying on the quality of that transformer. And I think that's the biggest weakness of this particular circuit. Not to mention, who knows if this charging circuit is as good and, say, sophisticated as this one. Maybe this one can detect issues with the battery and it can stop charging, things like that. So it's hard to say really, because we don't have the marking, so we don't have the data sheet for this IC. So for me personally, if I were gonna pick which one to use, I would generally tend to want to use the USB version. And that's because you can charge it off all sorts of things, like USB power banks, like I was showing, like this one. Or you can use your own high quality power supplies, or you can plug it in into the car, into your like USB port in the car and charge your radio. There's lots of options there. But the AC one, on the other hand, not so much. Now, the thing about this one, though, is it probably would be easy to mod this and add a USB Type-C power delivery input. You could just bypass this high voltage section entirely, connect the output of your power delivery input. There are little boards you can buy that have a USB-C jack on those, and those will negotiate, say, 9 volts or 11 volts or 12 volts. You can just feed that into the capacitor, and I bet you this circuit here probably could handle 12 volts without issue. And then that would give this thing, obviously, you could plug it into a USB-C bank like this, which supports up to 20 volts on the power delivery. And then that would alleviate any safety concerns you might have for this high voltage primary side of this board. Now, since the battery on the radio just has battery voltage available on the back, I'm now curious to see if we plug USB Type-C into the radio directly, we should be able to see or monitor a change in the voltage on the battery terminals. Or to be honest, we could just go into the menu and we can look at this voltage right here and see if it's actually charging. So let's plug in this USB Type-C power delivery cable and see if this voltage goes up at all. So that did absolutely nothing. So that's not charging. At least on this radio, it's not charging. This radio, I don't have the aftermarket firmware on it. Let me load the new firmware because I don't think this has that whole battery thing on. Oh, no, it does. 8.3? Well, that's not accurate because that's the battery I just took out of this one. And this one said 8.11 whatever on it. Yeah, 8.15. So, I think what I need to do is I'm just going to flash the aftermarket firmware onto this radio, same one that's on here, so that we can see the more accurate voltage reading. We're updating the firmware on these radios. I have this little adapter thing I made. Basically, it's got this plug that goes into the side, and it's just a TTL converter. So RX, TX, and ground. That's all you need. So with the radio, we turn it off, hold down the transmit button, turn it on, you get the flashlight. It's now in programming mode. So we just pop this cable in like so. And now the UART here has a little flashing light. And right now the firmware is being flashed and that is blinking. And we got lots of activity there. The connector on the radio is kind of janky, or maybe it's my cable that's not super good. So you just, if it's not working, just make sure this is seated all the way into the radio. Okay, the radio rebooted. So the firmware is EEVBlog, I think it's called. And you can see now we have the battery indicator. And if we go to the battery volume, okay, well that's weird. Let's take that out. Maybe that's like that because, oh, there it says it right there, EEVBlog. I just have that turned off on my other one. Battery volume. Okay. Well, I guess the circuitry on this radio does not accurately display the battery voltage. What the heck? So that's faulty, I guess. That's kind of bogus. Let's check the actual battery voltage. So it's 8.04. So this one's not even accurate either. I wonder if that's something you can tweak in the firmware, because clearly that's not right. It'd be great if like you go into the menu item and hit up and down to actually adjust this stuff, but that doesn't seem to be adjustable at all. All right, well, either way, I guess what I can do, let's try to plug the USB cable in and we can monitor the voltage on the battery itself like this. So we're at 8.04. Let's plug in the USB cable. This is a PD cable, so it may or may not actually work. We might have to use this as standard A cable. No change there. And what I mean by A cable is I mean a C to A cable. And that's because some Type-C devices don't properly have the right resistors or whatever's necessary to tell a regular power supply like this to even supply 5 volts. So it won't supply anything. So I have this cable connected to a standard USB Type A. Oh, that's doing something. So let's see what this is now. Yeah, remember it was 8.04? So this radio is actually charging, at least through the standard USB-A cable. And let's try this radio, the one with the white screen. Let's go to the battery volume. There it is, 8.16. I mean, it's still too high, but at least it's better than the other one. Oh, this one charges as well. All right, cool. So both of these charge off USB-C, but you need to have a C to A cable, which incidentally the radio came with, but I will toss those cables out or recycle them because I don't trust those cables to work properly. It's like they might not have data signals. Yeah, okay, it charges. Oh, that's so cool to know. Okay, well, there you go. So in case you were wondering, there was a difference between these two radios with this flat front version versus the, I don't know, not flat front. If one charged with USB-C and the other one didn't, they both charge with USB Type-C. I don't know how good that charging circuit is, like if it will stop charging properly 8.4 volts or what, but I'm assuming it will. And the biggest problem seems to be the voltage divider or whatever for the DAC that's reading the battery voltage is clearly garbage. I happen to have one more of these radios. Let me grab it and let's see how far off that is. Okay, here's the other one we haven't tested yet. So let's start with the battery that's in here. So we don't know what the actual B plus is, but radio 1, radio 2, and radio 3. So B plus, we'll measure that in a second, but it's reading, and I left the menu, it's 8.15 volts. And with the radio powered on, the actual reading is 8.04. Let's transfer the battery into that radio. And we'll move this battery off to the side so we don't confuse it. Okay, radio 2, which is the flat one, 8.30 volts. Yeah, so it'd be amazing if in the firmware we had a way to adjust the actual calibration of the battery voltage. Okay, this one is also 8.15 volts. So that's interesting. The two that have the not flat front, these ones, have the exact same reading of 8.15, and then this one has a fake reading of 8.3. It makes you wonder if the microcontroller that's in the radio is responsible for charging the battery, or there's a separate circuit entirely. Because if there's not a separate circuit and it's the microcontroller, these two on the outside are going to undercharge the battery, but they're going to undercharge it a whole lot less than this radio. This radio in the middle might only charge to 8.4 volts and stop what it thinks is 8.4 volts, which will be about 0.25 volts less than the battery should charge to. It should charge to 8.4 volts, but this one is going to stop charging at 8.14 or 8.15 volts if it's the microcontroller. If the charging circuit, on the other hand, is a separate circuit altogether, then that means that it probably is fine, and all of these will charge the battery to the correct 8.5 or 8.4-ish volts, and the microcontroller will just see weird things. It does mean, though, that this middle radio is going to have fake battery reading. In other words, it's going to show that it's at 100% battery life for a lot longer than these will. The one that you can do is turn off the radio, push PTT and the button right below PTT and turn this on. And it says release keys. And this goes into an extra programming mode in the menu where you have more menu options. And let's go and see if there's anything to do. Okay, so there's a battery. Oh, BatCal. Oh, look at this. You can do it. Let's see if that changes the volt. Oh, okay. So this calibration. All right. Okay, cool. Well, we know that this is actually, the battery is closer to 8.04 volts right now. So let's do that. I didn't notice the original number that's on here, but my assumption is the BatCal number is different between these two radios. Okay, so now if we power cycle the radio, we should have a lower battery percentage left now. 86, right. Ah, that is so freaking cool. This firmware is amazing. There it is, 8.05. Let's see how accurate that is. Okay, maybe I need to calibrate it a little bit more, but that doesn't matter. It's close enough. Oh, this is so freaking great. I just love the community making this aftermarket firmware that just is so cool. It's so darn cool. Okay, well, let's check the calibration number on these. So it's up to 97, which we know is fake. So we hold down the buttons to go to that setup mode, release keys. Yeah, wasn't the other one, the number that was in there was like 18 something. So it was just a calibration thing that was different between the flat face radio and these. Okay, cool. So the higher the number, the lower the actual battery voltage is. So we'll go to 1972. How about that? Cool. Yep, 83%. I like it. I don't need a false sense of security for like a battery that says it's fully charged when it's not actually fully charged. So what was our value? 1972, I think we said? Or it was 1952. I think that's what we said. Cool. What else is in here? You can open up some bands for transmitting and stuff. Okay, there we go. We're at 83% with 1952. I'm just going to make sure to put that same value into this radio. Yeah, I was just slightly high on this one. So 1952. Interesting, it's a little lower on this radio. Oh, 8.05? Okay, yeah, that seems right. Let's measure what it actually is right now, the battery. It's 8.037, so 8.04. So whatever, 1952, close enough. Now all of these have the same battery calibration. Freaking cool. So when I have multiple radios like this, one thing I do like to do is I like to create a label, and then I just label these as like 1, 2, 3, 1, 2, 3, so I can kind of keep the batteries and the radios together. So I'm just going to quickly print out a label, and I'll cut these out with a pair of scissors to stick onto the batteries and onto the inside of the radios. So this kind of labeling just helps you keep track of what's what. Okay, these are all labeled. I just need to program this one with the same programming as these. I use Chirp to do that. I'll swap out the antenna. I have another one of these better antennas to put on this one with the orange screen. And this one has 95% charge. This was the battery that I was charging in this. And that's because right before this video, I actually had this up on the charger upstairs on another one of the USB chargers. So I'm kind of assuming that it would get to 100% when it is fully charged. And that battery calibration thing, well, I gotta say, is freaking awesome. So at least for me, I was using battery calibration of 1952 with this firmware. Sorry, that's hard to read, 1952. But you can figure out that battery calibration for yourself. Just use a multimeter that's somewhat accurate, measure the voltage on the back, and adjust that battery calibration setting until you have the correct reading on here that matches what your multimeter says. And then at least you should have a bit more accurate of a battery gauge on your cheap toy radios. And then as far as charging these radios over USB Type-C, we now know that all three of these radios do charge. So no matter which one you have style-wise, they both can charge from USB Type-C, but you have to use a C to A cable and not a C to C cable, because these seem to lack the correct resistors or whatever is necessary to tell the power delivery power supply to give the radio the 5 volts, which is pretty lame, to be honest. And then as far as the desktop chargers go, the USB one seems like a better charger, a safer charger in my personal opinion, but the mains AC one should work as well. Although, you know, you just have those slight safety concerns with the very inexpensively and cheaply made switch mode power supply that is on this thing. Yeah, it's just, there's no way to know without taking this apart how good or bad quality the little transformer is on here. And that's all that's keeping you safe from potentially getting mains voltage on these charging contacts, which would destroy the radio obviously as well, but it's bad for human health as well. And that's why I kind of avoid using stuff like this, because you just don't know how good quality this is. But if this is all you have, it is moddable to use external DC. You just have to give it 10 volts, which now that I think about it, it actually says that on the back here, doesn't it? It says secondary input DC 10 volts. So there you go, they're actually telling you what the correct voltage is. So you could just cut the end off this cable, bypass the entire high voltage section here, and just hook the mains cable, which has the little wire strain relief, up to the cap on the output side of the secondary, add a DC barrel jack female connector on here, and then you could just use an external power supply to power this thing off 10 volts, and then it's a whole lot safer than it is there. But at least this one with the USB has that boost converter and a whole IC that probably handles charging of the battery properly, which I think is a little bit better. So there you go. Hope you found that interesting. I hadn't seen personally any of this information about the charging stuff online, especially the difference between these two chargers and how safe they were. So I'm glad to make a video to kind of put it out there, and hopefully that helps the community a little bit. Although these radios are so well understood, I wouldn't be surprised if all the information that I've talked about here was already discovered and is on forum posts somewhere. But at least here it's all in one place. And if you pick up one of these radios, you can calibrate the batteries, and I'm rolling over cables, calibrate the batteries and use your chargers safely and charge via USB-C and all that kind of stuff. So cool. I hope you found this interesting. If you did, thumbs up. If you didn't, you know what to do. Huge thanks to my supporters. Names are scrolling up the side of the screen, and they make it possible to do this full time. So a huge thanks to them. And hit that subscribe button if you haven't already, and watch my main channels if you haven't already, and you know, all the other YouTube junk. And that is going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.